Welcome back to my YouTube channel. Already we have seen integrals of particular functions, and in this video we will see integrals of some more types. See, the first type is integration of square root of x square minus a square into dx. Second type is integration of square root of x square plus a square into dx. And the third type is integration of square root of a square minus x square into dx. I go for solution of first one. For given indefinite integral, I call I. So therefore I will write the value of I is equal to integration of square root of x square minus a square into dx. These are special type of standard integrals, and we solving these special type of standard integrals by using integration by parts method, integration by parts formula. See, in this given indefinite integral, we are having only square root of x square minus a square. So only one term is there. And you write this as square root of x square minus a square as square root of x square minus a square into 1. Right? So I will write I equal to integration of square root of x square minus a square into 1 with respect to x, you write. And consider here the square root of x square minus a square is the first term, we call it as u, and next the constant one is the phi, and for this you call second term, and how to apply integration by parts formula. See, while applying integration by parts formula, first we take u outside, integrate p minus integration of inside bracket differentiation of first term. So first term means u, and after that integration of second term. So integration of second term means integration of p with respect to x. Yes, bracket complete. Again you do with respect to x. Right? So see, this is equal to, first to take u outside. So I will write u outside. It is square root of x square minus a square outside. Next you integrate v. So integrate v means 1 with respect to x, minus you write integration of differentiation of square root of x square minus a square, square root of x square minus a square. After that integration of 1 with respect to x, bracket complete. Next one with respect to x. Right? So this is by using integration by parts formula. See, first I kept u outside, integrating phi minus integration of inside bracket differentiation of u. So differentiation of u means we are having the value of u is square root of x square minus a square, and after that integration of v. So the value of v is 1, that is the integration of 1 with respect to x, bracket complete, with respect to x you write. So therefore I will write the value of I is equal to the square root of x square minus a square, you write as it is. Next integration of 1 with respect to x. So integration of 1 with respect to x is x, minus integration you write as it is. Yes, after this we are having a differentiation of square root of x square minus a square. We are having the formula of derivative of root x with respect to x. So derivative of root x with respect to x is 1 by 2 root x. And for this you have to apply chain rule. So first you differentiate root, and afterwards you differentiate the terms which lies inside the square root. Right? So differentiation of square root of x square minus a square is 1 divided by 2 into square root of x square minus a square. After that you differentiate this x square minus a square. differentiate x square minus a square. See, differentiation of x square is 2x minus differentiation of a square. So a square is constant, differentiation of a square is 0, and here you get only 2x, you write, into 2x, right? See, I repeat once again, differentiation of square root of x square minus a square with respect to x is 1 by 2 square root of x square minus a square. After that, you differentiate x square minus a square. Differentiation of x square is 2x minus differentiation of a square is 0. So 2x minus 0 is 2x. Next, integration of 1 with respect to x. Integration of 1 with respect to x is yes, x it is. X bracket complete and into dx you write. Into dx you write. So therefore I'll write the value of I is equal to yes, x into square root of x square minus a square, right? You multiply these two. So I'll write it as x into square root of x square minus a square. Next, minus you write this as it is, minus as it is, integrating sign also as it is. Now see, 1 into 2x, 2x into x, 2x square. You write it is a 2x square divided by 2 into square root of x square minus a square and into dx you write. This 2 get cancelled. 2 get cancelled. So therefore I'll write I is equal to x into square root of x square minus a square. X square minus a square. Next to write minus sign. Integration. See, in denominator we are having square root of x square minus a square, and in numerator we are having x square. So in numerator also you write x square minus a square plus a square. In numerator also required x square minus a square. See, in denominator we are having square root of x square minus a square, and we required in numerator x square minus a square, but we are having only x square. So how to do? Add and subtract a square. You do plus a square minus a square, or you do minus a square plus a square. So I'll write x square as it is, and along x square I'll write minus a square plus a square. I did here minus a square plus a square divided by this square root of x square minus a square with respect to x as it is. With respect to x as it is, right? Now, yes, after this I'll write I equal to x into square root of x square minus a square minus integration of, yes, I'll write this as x square minus a square, x square minus a square divided by square root of x square minus a square. After that plus I'll write a square divided by square root of x square minus a square with respect to x you write. Now after this I'll write I is equal to x into square root of x square minus a square you write as it is, minus integration of, see, a small adjustment here. This x square minus a square can be written as square root of x square minus a square to the power 2, because you can write x as square root of x whole square. See, we are writing x as square root of x into square root of x, and square root of x into square root of x means it is square root of x whole square. So likewise it is x square minus a square, and I am writing this x square minus a square as square root of x square minus a square to the power 2 divided by, I'll write square root of x square minus a square plus a square divided by square root of x square minus a square, yes, with respect to x you write. With respect to x you write. Yes, now I go for Yes, the value of I. So therefore I'll write the value of I is equal to x into square root of x square minus a square, right? Next minus, you write integrating sign inside bracket. See, this square root of x square minus a square and 1 square root of x square minus a square get cancelled, right? So what remains here? Yes, inside bracket square root of x square minus a square remains, and after that you write this plus a square divided by square root of x square minus a square, yes, into dx. You write as it is. Now therefore I'll write I is equal to x into square root of x square minus a square. Now split the bracket and you write minus integration of square root of x square minus a square into dx. See, minus integration of square root of x square minus a square with respect to x, minus into plus, we are having minus. This is very important. Minus into plus, minus, and after that you write integration of a square divided by square root of x square minus a square into dx. So therefore I'll write I is equal to x into square root of x square minus a square minus, see, integration of square root of x square minus a square into dx. At the beginning we took this value aside. At the beginning we took its value aside. So I'll write in place of this, I'll write I minus a square constant, you take outside, and after that you write integration of 1 divided by square root of x square minus a square with respect to x it is. Now I, and to take this minus sign this side, you make I and I together. So I plus I is equal to you write x into square root of x square minus a square minus a square, right? See, integration of 1 divided by square root of x square minus a square into dx. You see integrals of some particular functions and its value. Integration of 1 divided by square root of x square minus a square into dx is it is a log mod of x plus square root of x square minus a square mod complete, and after that you write plus c, right? So apply the formula of integrals of some particular functions, right? That is integration of 1 divided by square root of x square minus a square with respect to x is log mod of x plus square root of x square minus a square mod complete plus c. Now I plus I is 2i, so I'll write 2i equal to x into square root of x square minus a square log of mod x plus square root of x square minus a square mod complete plus c. So now therefore the value of I is equal to you take 2 in this side. Yes, whenever you are taking 2 in this side, it divides this term and as well as this term also. So therefore I'll write I equal to x by 2 square root of x square minus a square, next minus a square by 2 log of mod x plus square root of x square minus a square mod complete plus c. So therefore I means it is integration of square root of x square minus a square into dx. I means it is integration of square root of x square minus a square into dx is equal to x by 2 square root of x square minus a square minus a square by 2 log of mod x plus square root of x square minus a square mod complete plus c. So this is required value of the given indefinite integral. And see, in some other textbook they took in place of C is C1. In the place of C they took C1, and after that they are taking 2 in this side, and they return C1 by 2, and C1 by 2 is C. So that is also correct, right? So in the place of C, you take, if you want to take C1, you write C1, and after that you take 2 in this side, it becomes C1 by 2, and C1 by 2 is nothing but S constant C, right? So this is a very important result. You remember, integration of square root of x square minus a square into dx is equal to x by 2 square root of x square minus a square by 2 log of mod x plus square root of x square minus a square mod complete plus c. Remember, we are having some examples on this one. After this, I go for second type. For second type, we follow the same procedure. We follow the same method. See, second type is type number 2. Type number 2 is integration of square root of x square plus a square into dx. So type number 2 we are having. So type number 2 is integration of square root of x square plus a square into dx. So I go for solution of this. So once again we follow the same method, and I call this as I. This is given indefinite integral. So therefore I will take the value of I is equal to integration of square root of x square plus a square into dx, and we are solving this by using integration by parts method, integration by parts formula. So we are having only one term here. Integration of square root of x square plus a square into dx is there, and we are having only one term, and how to write the square root of x square plus a square as square root of x square plus a square into 1, right? So this is equal to, right, integration of square root of x square plus a square into 1, you write, into dx, and yes, you call it as u, and this is v. You call this is u, and this one is v. So now this is equal to, so first you take u outside, you take u outside, and you write yes, this u as it is, that is square root of x square plus a square as it is, integration of v with respect to x, 1 with respect to x, minus integration of differentiation of u. So differentiation of u means differentiation of square root of x square plus a square. Next, integration of 1 yes with respect to x, bracket complete, and after that we are having with respect to x, right? So this is by using integration by parts formula. U outside, integration of u with respect to x minus integration of differentiation of u, and in place of u we are having square root of x square plus a square, integration of v. So in place of v we are having 1, hence I written integration upon with respect to x, bracket complete, with respect to x. This is by using integration by parts formula. So now this is equal to, I will write square root of x square plus a square as it is, integration of 1 with respect to x. So integration of 1 with respect to x is x. I will write into x it is, into x you write minus integration. Next, see, differentiation of square root of x square plus a square with respect to x. Differentiation of square root of x square plus a square with respect to x. Differentiation of square root of x square plus a square with respect to x. It is 1 divided by 2 into square root of x square plus a square. Next, we differentiate the term which lies inside a square root. First, we differentiate root, and after differentiating root, we differentiate the term which lies inside the square root. And see, inside the square root we are having x square plus a square. So differentiate x square. Differentiation of x square is 2x plus a is constant. Differentiation of a square, yes, a square is also constant. Differentiation of a square is 0. And after that we are having integration upon with respect to x is, yes, x you write, Yes, bracket complete, and finally you write with respect to dx, right? So therefore I'll write the value of I is equal to I'll write, see, you multiply these two and you get here x into square root of x square plus a square, x square plus a square. Now minus you write, integration of 1 into 2x plus 0. So 2x plus 0 is 2x, 2x into x, 2x square. 2x square into 1, you write 2x square divided by 2 into square root of x square plus a square into dx. You write this 2 get cancelled. So therefore I'll write I is equal to x into square root of x square plus a square minus integration of x square divided by square root of x square plus a square with respect to x. Now I equal to, you write x into square root of x square plus a square as it is. Now see, minus integration you write as it is. To apply integration for this one, you write it in the standard form and see, in denominator we are having square root of x square plus a square. Hence it is required x square plus a square in numerator also. But you are having only x square in numerator. And that's why you do add and subtract a square. You do plus a square minus a square. So I'll write here x square plus a square I'll write, along with plus a square I'll write minus a square. If you cancel these two, again you'll get this equation divided by, you write a square root of x square plus a square into dx. You write. So next I'll write the value of I is equal to. So therefore I is equal to x into square root of x square plus a square minus, so I'll write it in standard form. So first I'll write x square plus a square divided by square root of x square plus a square. Next I'll write minus a square divided by square root of x square plus a square, bracket complete, into dx it is, bracket complete into dx. So therefore I'll write the value of I is equal to x into square root of x square plus a square minus integration, you write inside bracket, see, this x square plus a square, this x square plus a square can be written as s square root of x square plus a square to the power 2. If you simplify this, again you get x square plus a square divided by square root of x square plus a square, you write, minus a square divided by square root of x square plus a square, you write, and bracket complete into dx it is, into dx. So now see, this square root of x square plus a square and 1 square root of x square plus a square form the power 2 get cancelled. So therefore I'll write the value of I is equal to, so I equal to, I'll write x into square root of x square plus a square, right, as it is, minus integration of see what remains here, integration of square root of x square plus a square into dx. You split the bracket. So here we are having only s square root of x square plus a square. So integration of square root of x square plus a square into dx. You get here. So square root of x square plus a square into dx. Now see, this minus into minus, this minus into minus is plus. So plus you will get you will get integration of a square divided by square root of x square plus a square with respect to x. So therefore I equal to x into square root of x square plus a square minus integration of square root of x square plus a square with respect to x. Integration of square root of x square plus a square with respect to x. At the beginning, we call this as I. So you write I plus a square is constant, you take outside. A square is constant, you take outside, and you get here integration of 1 divided by square root of x square plus a square with respect to x. So therefore, you take minus sign this side. You take minus sign this side, it becomes I plus I, and I plus I equal to 2I. See, I, and you take minus sign this side, I plus I equal to 2I is equal to x into square root of x square plus a square, square root of x square plus a square plus a square, you write. Now, yes, you apply integrals of particular functions for this one. You apply the formula of integrals of some particular type of functions. That integration of 1 divided by square root of x square plus a square into dx. Integration of 1 divided by square root of x square plus a square into dx is log of mod x plus square root of x square plus a square mod complete, and after that you write plus integrating constant of c. Right? So now we take 2 in this side. It becomes I equal to x by 2 square root of x square plus a square plus a square by 2 log of mod x plus square root of x square plus a square mod complete plus c. Right? So therefore I means what? I means it is integration of square root of x square plus a square into dx is equal to x by 2 square root of x square plus a square by 2 log of mod x plus square root of x square plus a square mod complete plus c. This is a second type you are having. Remember, a very important formula it is. Integration of square root of x square plus a square into dx equal to x by 2 square root of x square plus a square by 2 log of mod x plus square root of x square plus a square mod complete plus c. And after this we are having third one. Third one, it is integration of square root of a square minus x square. So I go for third type. For third type also have to follow the same method which is used in solving the first and second one. So now I go for type number 3. So type number 3, I will write here given. So I is equal to, you are having integration of square root of a square minus x square into dx. It is yes, type number 3. Now again how to apply integration by parts formula for this one. So I'll write I is equal to integration of square root of a square minus x square into 1 into dx, you write. Alright? See, we are having just here square root of a square minus x square, and I written the square root of a square minus x square as square root of a square minus x square into 1 into dx. Now I have to apply integration by parts formula. So you write as square root of a square minus x square outside, integration of 1 with respect to x minus integration of differentiation of square root of a square minus x square. Next, integration of 1 with respect to x, bracket complete, with respect to x, you write. With respect to x, you write. So therefore I is equal to square root of a square minus x square as it is. See, integration of 1 with respect to x is x minus integration of differentiation of square root of a square minus x square. Differentiation of square root of a square minus x square is 1 divided by 2 into square root of a square minus x square. And after that, see, differentiation of a square minus x square you do. First, you did differentiation of square root of a square minus x square. So differentiation of square root of a square minus x square is 1 by 2 square root of a square minus x square. and after that you find the derivative of term which lies inside the root, and you find the derivative of this a square minus x square. So derivative of this a square minus x square is what? A square is constant, so derivative of a square is 0 minus the derivative of this x square, it is 2x, bracket complete. And after that we are having integration upon with respect to x. So integration upon with respect to x is x, bracket complete, and finally you write into dx, right? So therefore I'll write I is equal to square root of a square minus x square into x. It is x into square root of a square minus x square minus integration of, yes, now see, minus 2x into x, minus 2x square. You write minus 2x square divided by 2 into square root of a square minus x square, you write, bracket complete, into dx, you write, into dx, you write, just 2 get cancel, 2 get cancel. Next I'll write I equal to x into square root of a square minus x square, you write as it is, minus, you write, next integration of we are having, it is the minus x square divided by square root of a square minus x square, bracket complete, with respect to x. So therefore I'll write I is equal to x into square root of a square minus x square minus integrating sign, you write, integrating sign, you write. Now see, this is minus x square, minus x square. See, in numerator we are having minus x square, and denominator we are having square root of a square minus x square. To integrate this, you first write this is in standard form. So it means required a square minus x square in numerator also, but you are having minus x square only. So do here plus a square, and along with plus a square you do minus a square. That is, you do add and subtract a square. You write plus a square minus a square and keep minus x square as it is. Divided by, you write, square root of a square minus x square, bracket complete, with respect to x, with respect to x. So now, yes, I'll write the value of I is equal to, so therefore I is equal to x into square root of a square minus x square minus integration of, you write this as a square minus x square divided by square root of a square minus x square minus a square divided by square root of a square minus x square into dx. See, a square minus x square divided by square root of a square minus x square are written, minus a square divided by square root of a square minus x square into dx are written. So now I equal to this x into square root of a square minus x square, you write as it is, minus integration sign as it is, this a square minus x square, this a square minus x square, you write, square root of a square minus x square rest to square divided by square root of a square minus x square minus, you write, a square divided by square root of a square minus x square into dx, right? So this square root of a square minus x square and 1 square root of a square minus x square from the power 2 get cancelled. So therefore I'll write I is equal to x into square root of a square minus x square minus integration of, you'll get square root of a square minus x square, next minus a square divided by a square root of a square minus x square, bracket complete, with respect to x. Yes, after this I equal to, I'll write, yes, I'll write I is equal to this, you write as it is, x into square root of a square minus x square as it is. Now split this bracket, so minus, you write, integration of square root of a square minus x square, you write, minus integration of square root of a square minus x square into, yes, dx, you write. Next minus into minus we are having plus, minus into minus we are having plus, Next, integration of a square divided by a square divided by a square divided by, you write a square divided by square root of a square minus x square with respect to x it is. So therefore I is equal to x into square root of a square minus x square. See, minus at the beginning we call this value as I. We call this value as I at the beginning of the answer. So I call this is I plus a square constant integration of 1 divided by square root of x square minus x square with respect to x. That is the formula of integrals of some particular type of functions. That is sine inverse of x by a. It is sine inverse of x by a and plus c, you write. So you take minus sign this side, it becomes 2i equal to. You take minus sign this side, it becomes I plus I is 2i is equal to x inside the root a square minus x square plus a square sine inverse of x by a plus c. Now take 2 in this side. Yes, it becomes x by 2 square root of a square minus x square. Next plus a square by 2 sine inverse x by a plus c. Right? So I means what? It is integration of square root of a square minus x square with respect to x is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a plus c. So this is a required value. It is the required value of the given indefinite integral. See, these 3 types are very important. You practice it, and for the examples on this, you see next video. In next video, I will solve the examples related to type 1, type 2 and type 3. Right? So please share and subscribe my channel. Thank you for watching.